All right, let's do an example of the second derivative test, and I think you're going to see that this is fairly easy, luckily. So we want to find the relative max or minimum of this function right here, 10 minus 5x squared. So to do that, first let's find the first derivative, which is just going to be equal to negative 25x, because the 10 goes away and we just get negative 20. I'm sorry, that should be negative 10x, excuse me. Made a mistake. Everybody makes mistakes. First derivative would be negative 10x. And let's go ahead and find the second derivative, which would be negative 10, because the x just becomes a 1 and we get just negative 10. Well, that's very nice. Now let's find the relative max or min. To do that, we need to find out when the first derivative is equal to 0. So we solve the equation 0 equals negative 10x, and the only solution to that is x equals 0. So we have a relative max or min at x equals 0. So is it a max or a min? Well, let's go back to the original to the second derivative. Notice that the second derivative is negative. So remember from what we said before, if the second derivative is negative, then that means it's a max. And we're done. That's it. So if I plug in 0 to the original function, I get 0, 10, which is going to be a relative maximum. The reason 0, 10 is a relative maximum is because think about what this graph looks like. If I plug in 0, I get 10. It'll look kind of like this, an upside down parabola. This parabola is concave down the entire time. That's why its second derivative is negative the entire time. It's always as we go from left to right, it's always accelerating or turning towards the negative direction. Because of that, the second derivative is always negative, which produces a maximum where the maximum occurs. That's it. That's all we had to do on this one. In the next video, we'll look at the next example.